In today's lecture, we are going to discuss total quality management and how organizations implement it. TQM is the management of an entire organization so that it excels in all aspects of products and services that are important to the customer. TQM refers to a quality emphasis that encompasses the entire organization from supplier to customer. TQM stresses a commitment by management to have a continuing company-wide drive towards excellence in all aspects of products and services. Quality expert Edwards Denning used 14 points to indicate how he implemented TQM. We have developed this into 7 concepts of an effective TQM program, out of which 5 of those concepts will be covered in today's lecture. TQM process requires a never-ending continuous cycle of improvement that covers people, equipment, suppliers, materials, and procedures. The basis of the philosophy is that every aspect of an operation can be improved. The end goal is perfection, which is never achieved but always sought. PDCA is a continuous improvement model of plan, do, check, act. The Japanese use the word kaizen to describe this ongoing process of unending improvement, the setting and achieving of ever higher goals. In the US, TQM and zero defects are also used to describe continuous improvement efforts. But whether it's PDCA, Kaizen, TQM, zero effects, the operation manager is a key player in building a work culture that endorses continuous improvement. Six Sigma is a program that is designed to reduce cost, improve quality, and reduce lead times. In a statistical sense, it describes a process, product, or service with an extremely high capability. For example, if 1 million passengers pass through the airport with checked baggage each month, a Six Sigma program for baggage handling will result in only 3.4 passengers with misplaced luggages. The more common Three Sigma program would result in 2,700 passengers with misplaced bags every month. The second TQM definition of Six Sigma is a program designed to reduce defects to help lower costs, save time, and improve customer satisfaction. Six Sigma is a comprehensive system, a strategy, a discipline, and a set of tools for achieving and sustaining business success. It is a strategy because it focuses on total customer satisfaction. It is a discipline because it follows the formal Six Sigma improvement model known as DMAIC. This 5-step process improvement model, number 1, defines the project's purpose, scope, outputs, and then identifies the required process information, keeping in mind the customer's definition of quality. Number 2, it measures the process and collects data. Number 3, it analyzes the data, ensuring repeatability and reproducibility. That means it gets the results that can be duplicated and others also get the same result. Number 4, it improves by modifying, redesigning existing processes and procedures. And number 5, it controls the new process to make sure performance levels are maintained. Motorola developed Six Sigma in the 1980s in response to customer complaints about its product and in response to stiff competition. The company first set a goal of reducing defects by 90%. Within 1 year, it had achieved such impressive results through benchmarking competitors, soliciting new ideas from employees, changing reward plans, adding training, and revamping critical success processes, that it documented the procedures into what it called Six Sigma. Although the concept was rooted in manufacturing, General Electric later expanded Six Sigma into services, including human resources, sales, customer service, and financial credit services. The concept of wiping out defects turns out to be the same in both manufacturing and services. Employee empowerment means engaging employees in every step of the production process. It is enlarging employees' jobs so that the added responsibility and authority is moved to the lowest level possible in the organization. Consistently, research suggests that some 85% of the quality problems have to do with materials and processes, not with employee performance. Therefore, the task is to design equipment and processes that produce the desired quality. This is best done with a high degree of involvement by those who understand the shortcomings of the system. Those dealing with the system on a daily basis understand it better than anyone else. When non-conformance occurs, the worker is seldom at fault. Either the product was designed wrong, the process that makes the product was designed wrong, or the employee was improperly trained. Although the employee may be able to help solve the problem, the employee rarely causes it. Techniques for building employee empowerment include number one, building communication networks, number two, developing open, supportive supervisors, number three, moving responsibility from both managers and staff to production employees. Number four, building high morale organizations. And number five, creating such formal organization structures as teams and quality circles. Benchmarking is selecting a demonstrated standard of performance that represents the very best performance for a process or an activity. Benchmarking is another ingredient in an organization's TQM program. The idea is to develop a target at which to shoot and then to develop a standard or benchmark against which to compare your performance. The steps for developing benchmarks are number one, determine what to benchmark. Number two, to form a benchmark team. Number three, to identify benchmarking partners. Number four, collect and analyze benchmarking information. And number five, to take action to match or exceed the benchmark. Typical performance measures used in benchmarking include percentage of defects, cost per unit or cost per order, processing time per unit, service response time, return on investment, customer satisfaction, and customer retention. In the ideal situation, you find one or more similar organizations that are leaders in the particular areas that you want to benchmark. Then you compare yourself against them. The company need not to be in your industry. Indeed, to establish world-class standards, it may be best to look outside your industry. This is exactly what Xerox and Mercedes-Benz did when they went to LL Bean for order filling and warehousing benchmarks. Xerox noticed that Bean was able to pick orders 3 times faster. After benchmarking, Xerox was immediately able to reduce the warehouse cost by 10%. Mercedes-Benz observed that Bean Warehouse used flowcharts to spot wasted motions. The auto giant followed the practices and now relies more on problem solving at the worker level. Benchmarks often take the form of best practices found in other firms or in other divisions. Likewise, Britain's great Ormond Street Hospital benchmarked the Ferrari racing team's pit stop to improve one aspect of medical care. When an organization is large enough to have many divisions or business units, a natural approach is the internal benchmark that are usually much more accessible than from outside firms. Typically, one internal unit has superior performance worth learning from other units. The philosophy behind just-in-time system is of continuous improvement and enforced problem solving. Just-in-time systems are designed to produce or deliver goods just as they are needed. Just-in-time is related to quality in 3 ways. Number one, it cuts the cost of quality. This occurs because scrap, rework, inventory investment, and damage costs are directly related to inventory on hand. Because there is less inventory on hand with just-in-time, costs are lower. In addition, inventory hides bad quality, whereas just-in-time immediately exposes bad quality. Number two, just-in-time improves quality. As just-in-time inventory shrinks the lead time, it keeps evidence of errors fresh and limits the number of potential sources of error. Just-in-time creates, in effect, an early warning system for quality problems, both within the firm and with vendors. Number three, better quality. It means that less inventory and a better, easier to employ just-in-time system. Often the purpose of keeping inventory is to protect against poor production performance resulting from unreliable quality. If consistent quality exists, just-in-time allows the firm to reduce all the costs associated with the inventory.